Hi, I'm Brian from Simply Brian Enterprises, and welcome to my channel. It's been a couple weeks since I've posted any video, and that's because I've been having some technical difficulties in the studio. Hopefully I've got those ironed out and we can get back on track. This week's lesson is the homework solution for TopTechBoy's Raspberry Pi class, lesson number 11. Before I begin, I want to kind of go back a couple weeks to lesson number 7, when we built what we call the latching circuit. We pressed and released the button, the light came on, and it stayed on until we pressed and released the button again, then it went off, and it stayed off until we pressed and released the button again. This week we're doing something very similar, but instead of just one LED, we're actually going to use a multicolor LED. We're going to use a red, green, blue RGB LED, which is basically 3 LEDs in one package. That also means we're going to need 3 buttons instead of just one to control the red, green, and blue channels. As I normally do, I'm going to first walk you through the hardware, then we'll run the program, and then we'll look at the code. So I'm going to come down to the hardware. This has obviously changed in the last couple of weeks. I've been running the same configuration for a number of weeks with the 5 LEDs and the push button, and now unfortunately I had to take that apart and wire up something different. So the first thing you'll notice is that I'm using pull-up resistors on my 3 push buttons. And I kind of went back and forth on whether I should be doing pull up or pull down. I prefer pull up because the way the pull up works is that when it's sending 3.3 volts into the pin, it's using a resistor, it's using a current limiting resistor. And then when you press the button down, it's shorting it to ground rather than the other way around. I don't like the idea of sending a full 3.3 volts into the Raspberry Pi GPIO pin. Purely preference, it's safe to do, but just the way it works out, I prefer to do it as a pull-up button. I also want to talk about the resistors I'm using on the RGB LED. Normally you would use some smaller resistors, something around like 220 or 330 or 470 ohm. And this one, I've got some fairly large resistors so that the camera shows it a little more accurately. I have a 3.9K on the red channel, a 4.7K on the blue channel, and if you can believe it, I've got a 10K on the green channel, trying to get the color balance right for the camera. If I look at it here, I can barely see it on and off, but the camera picks it up very nicely. So with that, let's go ahead and grab the right mouse here. There we go. And let's run the program and see how it works. So the first thing it does is it goes through a little bit of a test cycle, red, green, blue, just to make sure everything with the LED is working properly. I'll try to sit in the frame a little better so you can see my hand. There we go. So now if I press, notice I don't have the correctly colored keycaps. So what I have is I have Paul in a red shirt, Paul in a green shirt, and Paul in a blue shirt to designate the red, green, and blue buttons. So I'm going to hit the red button, light goes on. Hit the red button, light goes off. Green on, green off. Blue on, blue off. Red on, blue on. Hey, look at that. That's a nice purple. Red off, blue off. Green on, red on for a very nice yellow color. Yellow is a tough color to mix, so I'm glad that one turned out okay on camera. But wait a second. What's this black button over here? Does this do anything? Oh, it turns the light off. Cat talk. Cat talk. Cat talk's not allowed. Strike 1. Strike 2. Strike 3. Uh-oh, cat talk. We're out of here. We gracefully exit the program with too much cat talk. All right, let's take a look now at the code. Before we get to the code, I need to show you something important. So I want to explain a little bit about RGB LEDs in case you're not familiar. So the idea of an RGB LED, let me flip over to the bigger camera here. The idea of the RGB LED is we're basically taking 3 independent LEDs and we are combining their leads together. And how do you do that? Do you combine the cathodes or do you combine the anodes? And the answer is yes. So we have, first of all, we have what is called a common cathode type RGB LED. And you can see here what I've done is I've taken the red, green, and blue cathodes, put them in one single column in the breadboard, and then tied it to ground with this jumper. Then I've taken the anodes to a resistor and to its leads. So if I want to light the red LED, I'm going to put ground to the ground rail, and I'm going to put plus 3.3 to the red to light the red, or to the green to the blue, you get the idea. There's another type, though, called the common anode, which is the exact reverse. Instead of the cathodes sharing one pin, we actually tie the anodes to one pin. And instead of sending it ground, we send it a constant 3.3. So in order to light the red LED in this configuration, I'm going to put 3.3 volts to the positive rail, and there's a resistor from the cathode to the red lead, and I'm going to tie this, instead of to voltage 3.3 or true, I'm going to tie this to ground or false to light the LED. And the reason that's important is because the only RGB LEDs I have are common anode, which makes programming a little interesting because that means it's completely backwards from the way you would think. Instead of to light the LED, instead of setting it to true, I'm going to set it to false to light the LED, and then true to turn it back off. So I needed to point that out because we're going to see that in the code, and I didn't want anybody getting too confused. Maybe you're already confused. Sorry if I did that. All right, so as usual, I'm bringing in rpi.gpio as pi pins, importing times, setting up my talk pin and counter, I should say. And instead of doing arrays this week, I decided to try using Python dictionaries. And the reason I'm doing that is because I start to get confused when I do array indexes 0, 1, 2. Okay, well, which one is red? Which one is green again? It makes it so much easier if I have my dictionaries defined as red, green, and blue. So this way, when if I want to read the input pin for blue, I just read the input pin blue, rather than trying to remember, is that 1 or 2, or where's the index start again? A little less confusing to read the code. Well, maybe a little more confusing to write it, but to read it, I think it's a lot more readable. So here I have my output pins set up, I have my input pins set up, and of course my cat talk pin set up. And here's where I did a little explanation of the difference between a sourcing current and a sinking current. So when I have my common cathode RGB LED, and I send it 3.3 volts to light the light, that's called a sourcing current, because we're going from 0, where's my hand? We're going from 0 to 3.3, so we're going up, so we're sourcing. Whereas with a common anode, we do what's called a sinking current. We always have 3.3 until we want to turn it off, or turn it on, and then we go to 0. We actually, instead of sourcing it going up, we sink it to go down. That's called sourcing and sinking current, just fancy words for what I've already described. And so as you can see, to turn them off, to start them as off, I'm going to set them to true, the inverse, because it's a common anode. And then I'm going to do my little cycle of red, green, and blue. So I'm going to do a false, half a second true, false, half a second true, false, half a second true. So this way I flicker them on red, green, blue, and you get the idea. So then we come down to our while loop where I'm going to be waiting for input. And I realized that previously I've been doing just a while true, and then further down in the code I have my little exit counter as basically an if statement. And I realized that it would actually be more efficient if I just decided that when we hit that exit counter, when we hit that limit, just bail out of the while loop and exit the program gracefully by putting all the exit lines at the bottom. This also really helps for debugging, to make sure that I don't have any syntax errors in the code before I really dig into the inputs and outputs. I can just go up here, set my cat talk counter to 4 or something, and then I just run through this and gracefully exit the program. Makes for a nice debug. So anyway, thought I'd point that out. So once we're into the while loop, again, like I've done before, I'm writing the output every single time through the loop. Go through the loop, write the output. Go through the loop, write the output. Go through the loop, write the output. And the only time something changes is if I press a button. So here I have my input, which again, I'm using a pull up button, so it's false. Pressing it down is false. Are you confused yet? So you press the button down is false to turn the true LED that's off to false to turn it on. You confused yet? I'm confused. That's why I had to explain it just to unconfuse myself. All right, so then we get to, we're holding down the button. We go into this while loop while the button's being held. Button's released. Here we're going to flip the value red, so true becomes false, false becomes true. Green, same story. Blue, same story. We come down to the cat talk button, and we have this same code of hold down and then release, and we are going to increment the cat talk counter. We're going to turn off the LEDs, and we're going to print a warning message that you've been talking about cats, and if you keep that up, we're going to exit the program. You should also notice that when I hit another color button, it resets the counter back to 3 strikes again. And of course, eventually we have 3 strikes, too much cat talk exiting. I'm going to set these to true to turn the LEDs off and clean up the pins. So that was kind of long-winded, and I hope I didn't lose anybody because I was doing some kind of confusing stuff this week, but I think this is going to benefit me in the long run by doing things the way I did. Time will tell. So looking forward to our next one, lesson 12, which is taking exactly what we just did and moving it from the latching circuit to a PWM circuit. That'll be fun too, and you'll see that next time. If you like this video, be sure to like and subscribe. I'm curious of anybody who's watching this, if you have a thought on using Python dictionaries versus arrays. I would love to hear your comments below, so please comment. Until then, until next week, thank you. Have a good day. Brian from Simply Brian Enterprises, thanks for watching.